everyone. Good evening to we are from group 2 and today we are going to present our group assignment. Before we proceed our presentation, let us introduce ourselves. Next slide. This is our group members and I am Tan Jing Shen. My student ID is 122010395.
Hi, my name is FAZIELLA binti Abdul Rahman. My student ID is 12201039992.
Hi, my name is OLIVIA JURAINI and my student ID is 122010401.
Hello, my name is SITI UMAIRA binti SINADI and my student ID number is 122010394.
And hi, my name is FARASHIKA binti AMJARANI and my student ID is 122010410.
And first, the cluster 1, I will present it. The first one is the definition of simple machine. Okay. Simple machine is a device containing only a few moving parts which can be used to change the direction or magnitude of a force applied to it. And, and a simple machine is a basic tool designed to assist in performing complex physical activities. And then there are six of the most popular simple machine. And the symbol of the machine is, the first one is inclined plane. Inclined plane is a simple machine with no moving parts, and it is easy to move object to higher or lower surface. And then it also used to us help move the heavy objects. And then the advantage of this machine is if the slope not steep, because less force will be needed to move an object up or down the slope. And then the other example of inclined plane is sidewalk ramps, highway access ramp, inclined conveyor belts, and the last one is switchback roads. And then second simple machine is wear and excel. Wear and excel is make our work easier by moving objects across distance. And then the wear and excel greatly reduce the friction involved in moving an object. And then the wears that returns with the excel to cause moving. The wear the wear is one of the most significant invention in the history of the world. For example, before invention of wheels, there are amount of load and the distance through which we could carry the load over land was limited. For example, it is easier to roll a 2,000 kilogram block of stone using logs placed underneath it than to push it. Okay, that's the picture example of wear and excel. Okay, the next one is pulley. Pulley is one of the simple machine, and it also perfect example for kids to use change the force direction. It needs someone to apply a force that holds the stone up to lift it into position on the pyramid. And then the force that required that can be decreased by using system of multiple pulleys. And then the example of pulley includes flagpoles, sail, fishing nets, rock climbing, cranes, and the last one is window covering like blinds. Okay, that's all from me. My friend will continue the present.
So next is screw. The function is to hold something together or lift something. It is an efficient tool to hold things together because of the threading around the shaft in a screw. The thread grips the surrounding material like teeth, so there will be secure hold. There are several examples of screw, including screw, bolts, and spiral staircase. Next, next is lever. Lever ke lever? Next is lever. Uh, a simple machine lever is a tool that can be used to open or close something, and levers can also be used to lift things. A mechanical device that has fixed leg arm and increase the apply force is called increasing the torque, while decreasing the apply force is called decrease the torque. For example, is a hammer that we use to pry nails loose. The last one is wedge. A simple machine wedge is a device used to break substances into smaller pieces. The force is applied to the white heat area of the nail. Other than that, a wedge is a common example of a nail. This example show an apply force that is concentrated in a small point. The force is magnified at this point to allow it to pierce torque object. For example of a wedge are an nail, jackhammer, fork, knife, and so on. Next is Siti Nashel Omaira to continue the presentation.
Okay, next I will continue with the presentation with the title link H. Next. Okay, so first I will introduce what is linkage. So linkage, or also known as kinematic chain, is a collection of links and join. So it can convert input motion or force into the desired or required output motion. So to make it simple, linkage is mean like something connection. So if there's linking or the fact of being linked, that is a linkage. So especially for some connection that look like chain, something follow with something. So that is linkage. And joint means connection formed at the knots of two or more links. After that, links mean rigid body that has at least two knots or joint. So Linkage mechanism can first modify of the component's direction, second move it in a certain way, and the last one is alter the force of things that move in a mechanical system. Next. Okay, so there is six type of linkage, and the first one is reverse motion linkage. So reverse motion linkage can change the direction of motion so that the output will move in the opposite way. Okay, so a fixed pivot point means a point, a knot that cannot move, stay at their place, make the direction of a rod to be reversed to another rod. And then, for example, like a folding clothes horse. So to make it simple, when you see the folding clothes horse, the top rod will move to the left, while the bottom will move to the right. So that is how it's function. Next, okay. The second one is parallel motion, or also known as push or pull linkage. So this linkage move together while staying parallel. So parallel motion linkage rely on two fixed pivots. Like I said before, fixed pivots mean something that stay at their place to make the input and output move through a link arm in the same direction. You can see at the picture in that slide. So the example is toolbox. Okay, first of all, parallel means two lines that move in the same direction but never will meet each other. So the toolbox, you can see when you open it, when you open the toolbox lid, an additional set of drawers will be spread out. So that is how it works. Next. So the third type is bell crank linkage. It enables the transformation of horizontal movement into vertical movement. So after the direction through a 90-degree angle, it can transmitting motion around a corner, like the picture that's shown, and then it can adjusting the fixed by adjusting the fixed pivot, the output force can be modified. So you can see this. The example is bicycle brake. When the lever of the brake is pulled, automatically the cable moves upward and forcing the brake to block the wheel, like this in the picture. Okay, next. And the fourth type is crank and slider linkage. It can convert rotary motion into reciprocating motion or vice versa. And then when a connecting rod connects the slider, which slide inside the tube, like the picture here, and then to the crank, or known as the rotating disc. So this cycle one is what we call crank or rotating disc, and then the slider is pushed and pulled by the crank as it rotates. So if you want to see this linkage, you can see the automobile engine, which it will igniting the fuel with the spark plugs. And actually, this linkage is developed by James Wood. Okay, next we will continue with Farashika.
Okay, so I will present the next point, which is threaded linkage. It is used rational input to turn a crank on a fixed pivot. Then it have a two movable pivots will be connected to one pivot by a rod. Uh, this linkage we can see example like car windscreen wipers or an old-fashioned sewing machine. Next, and the lastly is four-bar linkage. It have a simple linkage mechanism which have four separate parts which are referred to as link or or bars. The range motion for each body depends on the design of a four-bar linkage. For example, like a pair of locking pliers, and a 4-bar door temper linkage. Next is about most typical links. Binary links is connected to two different joints or nodes. Then the ternary link has a 3 joints or nodes. Next, quaternary link has 4 joints, and lastly, quaternary link have 5 joints or nodes. And next is Revelet joints that provide a single degree of freedom for rational motion between two links. Secondly is prismatic joints that allow for a single degree of freedom linear or translational motion between two links. And lastly is cylindrical joints that allow for both rotational and linear motion between links. Next. So the conclusion about this linkage is everyone needs to be aware of the importance and function of linkage mechanism because many mechanical devices that and things that have been used on a daily basis use linkage mechanism. So it will can carry out a variety of duties with ease because of development and design investment. That's all from me.
Welding safety is the topic that I have choose. I will briefly talk about what is welding. Welding safety identifying hazards before proceeding with job tasks in order to remove them, reduce safety risks, and maintain a safe work environment. Here are examples of types of welding. Welding is a fabrication process whereby two or more parts are fused together by means of heat, pressure, or both forming a joint as the parts cool. Welding is usually used on metals and thermoplastics but can also be used on wood. The types of welding is back gas welding, resistant welding, arch welding, newel welding, and solid state welding. Okay, next. Here are the examples of hazards in welding. The first one is health hazard. The health hazards are from gases and fumes. The welding fumes contain a mixture of very fine particles, including nitrogen, silica, zinc, and lead. The fumes have come from best and filter material, coating, painting, shielding gas, and chemical reaction. However, this fume can affect any parts of the body, including the lungs, heart, kidneys, and central nervous system. And the electrical hazard in welding process generally use low voltage. There is still a danger of electrical shock caused by wet work areas, cramped workspace, poor cable insulation, and faulty machine. And the next hazards is fire and explosion hazard. A fire or explosion can cause intense heat and sparks when near combustible and combustible material. Therefore, welding should only be performed in areas free or full of combustible materials. However, containers containing combustible or combustible materials should never be welded unless the containers have been purged or filled with inert gas. And the next hazard is trips and falls. The hazards are slippery surface, messy cables or hoses, and equipment. And the last hazard is compressed gas hazard. Gas welding uses fuel gas and oxygen, which are stored in high-pressure cylinders. However, most fuel gas are explosive. The oxygen will increase the flammability of any combustible and flammable material. Next. Here are the pictures for each hazard. Next. And these are the hazard prevention. For health hazard, workers use of fumes extractor and proper ventilation. And for electrical hazard, workers should use dry gloves, wear rubber-soled shoes, and proper grounded connection. And next is fire and explosion hazards. The workers should use suitable fire extinguisher and fire watches. And the next one is trip and falls hazard. The workers should always keep the working area tidy. And lastly, the compressed gas hazard. The workers should always secure the gas cylinders properly. That's all from me. Thank you.